አስፈላጊ ወይንም necessary የሆኑ ሁለት ፖይንቶች አሉ in a physics to be said that work is done. So we must have to be just obey two conditions. What are they? Let's see one by one. First condition, the force must be applied. The force must be applied. የሚተገበር ጉልበት ሊኖር ይገባል። አንድን ስራ በፊዚክስ ውስጥ ተሰርቷል ለማለት የሚተገበር ምን ሊኖር ይገባል ማለት ነው? ኃይል ሊኖር ይገባል ነው ፎርስ ሊኖር ወይም ደግሞ ጉልበት ሊኖር ይገባል። The force must be applied. The second condition, the object must be displaced. The object must be displaced. ጉልበት የተተገበረበት አካል ከአንድ ቦታ ወደ ሌላኛው ቦታ ላይ ምን ሊሆን ይገባል ማለት ነው? ሊንቀሳቀስ ይገባል። እነዚህ ሁለት ኮንዲሽን ያሟላ ማንኛውም ስቴትመንት በፊዚክስ ውስጥ ምን እንለዋለን? ስራ ተሰርቷል እንላለን ማለት ነው። So the work is done when the force is applied and an object must be displaced. So the point that you never forget in here is በዚህ ሂደት ውስጥ አንድ በጣም መርሳት የሌለባችሁ necessary የሆነች ፖይንቶች አለች። የመጀመሪያው ምንድን ነች? Look at the applied force. The applied force and distance moved must be what? Parallel. የሚተገበረው የጉልበት መጠንና ኦብጀክቱ እየተንቀሳቀሰበት ያለው አቅጣጫ እርስ በርሳቸው ምን ሊሆን ይገባል? parallel ሊሆን ይገባል። must be just parallel. So when these two conditions are satisfied, it's possible to say that work is done. So look at in here the essence of work. Look at the SI unit of work is what? Joule, which is labeled by J capital. Mean that 1 joule is equals to 1 Newton meter. አንድ ጁል ስንል ከአንድ ኒውተን ሜትር ጋር እኩል ነው። ጁል የሚያሳየን የወርክ ኤስአይ ዩኒት መሆኑን ነው። ስለዚህ አንድ ጁል ማለት አንድ ኒውተን ሜትር ነው ማለት ነው። So 1 joule is equals to 1 Newton meter. And again, work is scalar physical quantity. Scalar physical quantity. What I mean? When we express work, we never denote it by direction. Rather, we are going to just express using only magnitude. So due to that reason, work is a scalar physical quantity. The dimension of the work, look at the dimension of work is equal to we say that 1 joule is equals to 1 Newton meter, but 1 Newton is equals to, from Newton's second law, we have a description. 1 Newton is equals to 1 kilogram meter per second square. So 1 joule is equals to 1 into, instead of Newton, we are going to just express what? Kilogram meter per second square. Here have meter. So this description is equals to kilogram meter square per second square. So from this, it's possible to say that the dimension of the work is expressed in terms of mass, length, time. So the mass is 1, the length is 2. The second here, when we extract upward, we have an expression of. This is easily the way how we are going to just express that dimension of the work, mass, length, time. Since work is a derived physical quantity, but it is possible to express in terms of fundamental physical quantity. So when we express one derived physical quantity in terms of fundamental physical quantity, that types of expression is said to be dimension. This is the dimension of the work. So from this, let's back to the system. Let's consider this system. Let's consider the following system. Mean that this is horizontal plane, or let's consider it is a floor. When you put down a block, say types of block. And when we push by a force, the force is said to be the applied force, and the block is displaced. Eventually, you can just observe the block here. This is imagine. So this is the way how the block, when we apply a force on this block, the block can displace. So this is the distance that is covered by the block, labeled by S. So in case it is possible to say that the work done is equals to the force that is applied on the block times, if possible to say that the distance moved. This is the way how easily we're going to just equate. Since we're going just considering the horizontal plane, our theta is equals to 0, and cos of theta, which is equals to 0 degree, it is equals to 1. So it's possible that the work done on this block, the work done on the block, it is equals to, it is possible that the applied force times it what? Or let's say that this is the way we are going to just put down the dot product moment. This is the way how we are going to equate the work done on this block. When this applied force is inclined, what happened? Let's consider the force applied on where? On the block. On the block is inclined. Shown below. What I mean? Let's draw the system. And let's put down here, this is our block. So when we applied using a tension, this is said to be the applied force. And here we have an angle of theta. And assume the surface is smooth. Look at. Assume the surface is what? Smooth. So when we say that the surface is smooth means it seems like the frictional force is approach to 0, is not equal to 0, rather the frictional force is approach to 0. So how we are going to find the work done on this block? I mean that when the block is moved at a distance of such way here, because the block are here, so due to this applied force, it can just cover a distances and reaching on this part. So for say types of system, how we are going to finding the work done on this block? Then for say types of system, we are going to just finding the component of the force. First, look at. First, let's find the component of the force. The component of the force. How we are going to finding the component of the force? Using description. I mean that since the block is such way, here have an applied force, here have a theta, so it is possible that this one is the component of horizontal, which is F cos theta, or this one is the vertical one, possibly that, F sin theta. So, since the block is moving horizontally, in a case we are going to just considering the horizontal force only, because the block is moving on horizontal surface. In case we are going to considering the distance and the applied force must be parallel to be say what? To be say that work is done. And force, as you can just observe in this case. This is all about today's lesson regarding with work. So I think you have get some clue regarding with the work. I mean that when work is done, the first criteria to be said that the work is done must be the force must be just applied on objects, and an object must be just displaced. And in case possible to say that the applied force and the distance must be parallel. In the second option, or in the next video, I will show for you how the work is maybe zero, negative as well as positive. So today, I think we are going to just summarizing the concept of work as I can just explain for you. If you have any comment or suggestion, if possible to contact within a message. Up to that, I will say that goodbye. በዛሬው ትምህርታችን አጠር ባለ መልኩ ስለ ወርክ በፊዚክስ ውስጥ ተረድታችኋል ብዬ አስባለሁኝ። ጥያቄዎች ካላችሁ ያልገባችሁ ፓርት ካለም ኮሜንት ስር ይሄ ማለት ምን ማለት ነው የሚለውን ነገር ያስቀምጣችሁ በሚቀጥለው ቪዲዮ እንድሰራላችሁ እስክንገናኝ ድረስ